That's about it, right? Not winter. That's the other thing. Not winter. Right? Alright. Alright. Okay. Here's what I want us to do. I want us to, we're on page, what page is that? 77? No, this is not that page. What page are we on? What page am I on? What page am I on? I'm on S71. Another packet? We don't have 70 to 72. What? No line. So this, you guys have example 1, right? Right, what's on the next page? So example 1 is on page S70. The next example, language. Next example is on S72. So which one is this? This is S70. And then I go to S77. No, I'm on S71. Okay, I'm on S71. So now I jump to S72. Yeah. That's not what you have on S72, though, is it? Yes, it is. It is? Okay. All right. So let's do that then, shall we? So we're going to consider the function x cubed minus 13x squared plus 44x minus 32. And we're going to use the fact that x minus 4, and I wish they'd put this in parentheses, is a factor to factor this polynomial. What does it mean for it to be a factor? Well, divisible by what specifically, Brandon? X minus 4. So what do you think I should do with x minus 4 and this big guy right here? Divide it, or not divide, but divide. Divide it, yeah. So let's do that then. Let's do x minus 4 goes into x cubed minus 13x squared plus 44x minus 32. Go. You divide this up? Oh, sugar. I forgot to get to that, didn't I?
was trying to make you come over here and I was calling.
I'm sorry, no, you're right. You are right, you're right. You're right. You said it before, and I completely spaced out on it.
Sorry, don't even worry about it. I start crying a little bit. It's no big deal.
No, that's plus. Is that what you got?
Mr. Cook, I'm going to look up on the side. Right. Got it? You there? All right. So, now, can I factor this guy? Can I factor what I wrote here in red, which is what most of you guys got, Kaya? Can I factor this guy? So x squared minus 9x plus 8 is what factor? So how does that factor? So factor x squared minus 9x plus 8. Once you've found the factors here, right? These two things are the factors of this guy, right? And this guy is a factor of this, right? So this has three factors. What are the three factors? Think about it. Ethan, were you able to factor the red polynomial? You want to be brave? All right, what'd you get?
I did x minus 9x.
I'm sorry?
I did x minus 9x.
Okay. X. Okay, remember, it's going to be two binomials. Okay? So, here's how we factor this.
I got two things. Remember, when I multiply these things together, I do first times first, outer times outer, inner times inner, and last times last. And I multiply those all, or I add those all together. Now, the first term, x squared, is a result of this guy right here, right? So I get x times x. Now, let's look at the last term, 8. How does that factor? We're going to go 8 and 1, right? Because 1 times 8 makes 8, right? They're either going to be both positive, because a positive times a positive gets me a positive, or they're going to be both negative, right? Because a negative times a negative also gives me a positive. But this middle number is negative. Can I add two positive numbers together to give me a negative? No. So both of these must be negative. So I got x minus 1 and x minus 8. So now I have 3 factors for f of x. 2 of them are right here, yes? 2 of them are right here. Where's the third one? Where's the third one, Jordan? What does it mean to be a factor? Remember, we're always coming back to these definitions here. What does it mean to be a factor? Mason, what does it mean to be a factor? Answer my first question. What does it mean to be a factor? Yes, you're right, but what does it mean to be a factor? Okay. Right? I can divide it into something evenly, or another thing it is to be a factor is things I multiply together to get me something else, right? So, what do I multiply together to get me x cubed minus 13x squared plus 44x minus 32? What 3 things do I multiply together to give me that? I saw that. I saw that, Trey. I got your back. What 3 things do I multiply together? This is one thing, right? X minus 1 is a thing. X minus 8 is another thing. What's my third thing, Caden? X minus 4 is my third thing. Okay? Now, with those 3 factors, I can find the intercepts in my graph. My x-intercepts. Remember what an x-intercept is. What is an x-intercept? When it crosses the x-axis, right? What's the value of the function when it crosses the x-axis? I got a function, right? What's the value of my function there? And what's the value of my function there? And the value of my function there, right? So, remember how I find the zeros for my function. I set all my factors equal to 0. So, x minus 4 equals 0, right? There's one factor. X minus 1 equals 0. That's another factor. And x minus 8 equals 0. That's this guy right here. And then I solve for x. So what do I get for my values of x where the function equals 0? Yes, Gabe.
Constant form, constant 1.
All right, stop. So Gabe's giving me 2. X equals 4 is a 0. X equals 1 is a 0. What's my third 0? Josh.
8.
X equals 8. All right? So, when I draw my graph of this, I know it's going to cross the x-axis at 4, 1, and 8. Now, at which x values can the function change from positive to negative or from negative to positive? It's a weird question. Sounds weird. What does it mean? If I was to draw a number line, I'll do it on here so my viewers at home can see. I got 0 in the middle, I got all my negatives here, and I got all my positives here. At what point do I go from negative to positive? Do I go from negative to positive here? Am I getting warmer? Red hot now, right? No, I'm cold again. I'm positive now. I'm not going from positive to negative. Where did I change over? At 0. So, this is a fancy way of them saying, oh, right across the 0. What is so funny, you two? Do I got a boat hanging? No, I don't. I picked that stuff out a while ago. All right. Yeah, I'm kidding. Seriously, though, try to pay attention. All right. So, to sketch a graph of this, I need to know when this thing can change from negative to positive or vice versa. I need to know. Reason being, let's think about this. If I know where this thing crosses 0, right? When you come in the house, please shut this door. It's really hot out here today. It's fine, but just... So, to sketch a graph of this, we need to consider where the function is positive and where the function is negative. So I need to look at values between 4, 1, and 8. Okay? I need to consider that because I know it's 0 here. And I know it's 0 here, and I know it's 0 here. But what does it do in between? So let's pick a number between 1 and 4. 2. Okay? F of 2. So what I'm doing here is I'm putting, wherever I see an X, I put a 2. So now F of 2 equals, well, I'm sorry, not X, equals 2 cubed minus 13 times 2 squared plus 44 times 2 minus 32. What did I just do here? I put 2 in for X. Everywhere I see an X here, I'm replacing it with a 2. So this is really my set of directions on what to do with the number. Well, now it's 2 cubed, which is what? What is 2 cubed? 8. Minus, now we got to do a little bit of math here. What do I do first? Not multiply, but I do the exponent first, right? I do exponent before multiplying. So 2 squared is what? 4. 4 times 13. 52, that's right. Plus 44 times 2, which is, and then minus 32. And then I evaluate that. 8 minus 52, that's negative 44. Negative 44 plus 88 is positive 44. 44 minus 32 is 12. So it's positive. It's positive, right? I get a positive 12. So what does that mean? That means I'm I'm going to write this over here in the next, my content. That means when x equals 2, right? When x equals 2, I'm at a positive 12 someplace. Let's go by 2s. 2, 4, 6, 8, 10, 12. So right there. Remember what my zeros were. What were my zeros? 1, 4, and 8. Those of you guys that aren't paying any attention right now, they have very little sympathy for you come quiz time. Okay. So now I know that my function does something like this. It does something like that. I don't need to know exactly how high this goes. I'm just looking for the flavor of this graph. I'm looking for the characteristic. Okay? Now, I need to know what it does in here. So let's pick a number between 4 and 8. Should I go with 6? Let's go 6. So, when x equals 6, 6 cubed. Somebody do 6 cubed on a calculator for me, please. That's squared. 36 times 6 is what? It's 180, 198? 216? 216, okay. So 216 minus, now it's 13 times 36. 13 times 36 is what? 468. Plus, now it's 44 times 6. So that's 240 plus 24. That would be 264. All right? Brandon? All right? All right, Madeline? 264? 252? 44 times 6. What was it? 264? I feel like I'm talking to like 2 people right now. Like hell you are. Alright, now this is f of 6, right? We're evaluating our function at 6. So now we do 216 minus 268 plus 264 minus 32. And what do I get? Negative 20. Somebody corroborate Caden's? Negative 20? So I got 2 people here. Okay. So negative 20 all the way down here, right? All the way down here. So now my graph does something like this. I really should look over here and look over here. Let's pick a real easy number for over here. Let's pick 0. When x equals 0, 0 cubed is minus 13 times 0 plus 44 times 0 minus 32. Negative 32. So when x equals 0, my function is all the way down here someplace. Right? Negative 32. So it's going way down. And now, let's pick another easy number. Let's pick 10. Let's pick 10. 10 cubed is what? 10 times 10 is 100. Times 10 is 1,000, right?
Yes.
Yeah. 10 times 10 times 10. Minus, what's 10 times 10? 100 times 13. So minus 1,300. So I get negative 1,300, right? Negative 1,300. Plus 1,000 is negative 300. Yeah, let's do this on, so f of 10 equals 1,000 minus 13 times 100, which is 1,300, plus 44 times 10, which is 440, and then minus 32. So that's negative 300 plus 140. 140 minus 32, that's 108. Am I right?
Yes, you're right.
108. 108. So at 10, this thing's all the way up here someplace. And this shoots up. Now, does this thing approach 0 at any other place? Does it hit 0 at any other place? Can't. It can't. Because it only hits 0 at those three places when the factors equal 0, right? It only hits 0 at those three places. So this is eventually what your graph looks like. It goes down to it starts from negative infinity, goes all the way through this, right in this window, it zags a little bit, and then goes up to infinity again. That's what this graph does. That's what this graph does. Infinity is not a number. It's a concept. It basically means that think of the biggest number that you can possibly think of. That's the biggest number you can think of? Okay, I can find a bigger number than that. Right.
100 is trillion.
Plus 1.
100 trillion plus 1.
Plus another 1. We can go on forever. Now, it says to sketch a graph, we need to consider what the function is, whether the function is positive or negative on the 4 intervals. The 4 intervals are these. It's this interval, which is x less than 1, right? This interval right here. X is between 1 and 4, right? And then this interval. X between 4 and 8. And then the last interval is x is greater than 8. Those 4 intervals we need to consider to see what the graph is doing in those sections. Okay? How can we tell if the function is positive or negative on an interval between x-intercepts? We just did that, right? We plugged the value of x in between those intercepts, and we checked to see if it was positive or negative. Okay? That's all we did. And we answered all these questions. We answered all those questions. Okay, we answered those questions too. Oh my gosh, we got it right there. We got it right there. We did it already. We did that already. That was awful class. That was an awful class. I did awful there. I did awful.